Good evening to everyone. So today we will discuss on causes of autocorrelation. So last class we have discussed about what is meant by autocorrelation and what are the types of autocorrelations are there. How we can find out autocorrelations by using simple row values. So today we will discuss about what are the causes of autocorrelation, or sometimes they will ask the question that what are the reasons for autocorrelation or causes of autocorrelation thing. But so here when they are asked such kind of question that what are the causes of autocorrelation, simple you need to write what is meant by autocorrelation, and you need to write a formula also that that is equation how we can find that is AT is equal to rho ET minus 1 plus VT. So then we need to write what is autocorrelation values lies between minus 1 to plus 1. So if rho is equal to minus 1, what will happen, what it is, and if r is rho is equal to plus 1, what it is, if rho is equal to 0, what it is. So generally in economics formula we can write expected ui and uj is equal to 0. So that is called no autocorrelation. If expected ui and uj is not equal to 0, there is a autocorrelation problem. So basically, as I told you that in the last class, that why we can study what is the reason to study the autocorrelation. Nothing but when you are doing the regression analysis, you will get a autocorrelation problem. Generally, when you are using the time series data, you will get autocorrelation problem more. For example, when you are using a cross section data, you may get a problem, but there is a less chance to get the autocorrelation problem. So then we will discuss one by one what are the causes of autocorrelation. So why does autocorrelation occur? Sometimes they will ask that in some questions they will ask, so why does autocorrelation occurs? So there are several reasons to get autocorrelation in regression analysis. First one, inertia or fluctuation or sluggishness. Then we will discuss one by one what it is inertia or fluctuations or sluggishness. Then the second one, omitted explanatory variables. Omitted explanatory variable, nothing but when you are doing a model, when you are doing a regression analysis, so if you omitted, nothing but if you remove a unimportant variable, that unimportant variable also they may have some significant effect on dependent variable also. In that case also we will get autocorrelation problem. Then third one, misspecification of mathematical models. As so when you are framing a mathematical model, you need to take care about whether our mathematical model is good or in correct form or incorrect form. Then as well as incorrect function form also. For example, sometimes when you are using a model, so you can keep in mind that which model is suitable for your objectives or your target area, nothing more, target variables. And fifth one, Cobweb phenomenon. Sixth one, lag values. Lag also can influence that autocorrelation. Then manipulation of data. Then last one, that's a data transformation. So we will discuss one by one what is inertia, omitted explanatory variable, misspecification of mathematical models, incorrect form, Cobweb phenomenon, lags, manipulation of data, and data transformation. Yes. Then we'll discuss one by one. The first one, inertia or fluctuations. Okay. So what is inertia or fluctuation or sluggishness? See, when you are taking a data of economic data, for example, if you take GDP, price index, production data, or employment data, or business cycle data. So most of the economics data, that is a silent feature of economics data, is a inertia or sluggishness. Nothing but when you take a data GNP, so it may be always, it may be fluctuation, nothing but it may be ups and down, towards up, towards down. There is upward, nothing but when there's an increasing trend, there is a decreasing trend. If you take production, so year by year it may be increase the production slightly, some year it may be decrease, and automatically next year it may be increase like this. For example, when you take this data example GNP price indexes, production, employment, business cycle. See, if you take GNP, year by year, our GNP maybe increases. So there is not sluggish, nothing but fluctuations. So for sometimes it may be decrease. But when you compare with over a period of time, the present GDP is depends previous year GDP, right? So here in the case when the present year data is depends on previous, so you may get a calculation problem generally, because today is depends on last day. Nothing but today production is depends on last day. So when you are using this kind of data, for example, GNP, price indexes, employment, business cycle. So generally in our economics series data, generally we will get a problem that is a sluggishness or fluctuations. So if you observe any data in economics, generally the data cannot be constant over a period of time. So generally it may be fluctuation in over a period of time. For example, if you take into account GDP in 1950 and GDP 1960, 70, 80, 90, and 2000, 2010, and 2020. So if you compare this data from 1950 to 2020, so there may be fluctuations over a period of time, but it cannot be constant. If it is constant, we can say that there is no relationship between present year and last year data. So generally, when we are taking when you are considering the autocorrelation problem, see, generally in autocorrelation means it means only there is a relationship between present year error and previous year error term, right? So when you take into account this kind of data, you may get a autocorrelation problem. Then generally, if you take in account, you can note down a point that is successive observations are likely to be interdependent. Successive observations are likely to be interdependent. For example, if you take into account all the successive values or successive observations are likely to be interdependent. Nothing but there is a interdependent. Nothing but one can depend on another, another one depend on that one. There is an interdependent. The second reason or second cause is omitted explanatory variables. Omitted explanatory variables. So generally, we can exclude unimportant variables from the model. Generally, for example, when you take into account in your third semester in the multiple regression, so when you're taking about a multicollinearity problem, sometimes we will get a multicollinearity problem also. We will discuss later. But when you're taking, when there is a correlation between independent variables, you sometimes you may be remove unimportant variables from the model. For example, unimportant variables can influence the dependent variable at some level of significance. So generally we can exclude nothing but we can remove unimportant variable in the model. In some cases we may exclude variables. Sometimes we can exclude some variable. For example, if you take into account, so paddy yield is depends on area and production. Area in the sense the paddy, how much production per acre is depends on the total area and total production. See, when you observe to take into account, area and production are the independent variables. If you considering the both variables, so both variables have a significant effect on yield. But when you compare, the two variables are not an important. You may consider only one. So if you think that, so both variables are not good, if you take into account one, it may be good, for example. So in that case only you can remove one variable for either area or production. Okay. So sometimes if you take into account, involuntarily you may remove some variables from the model, which are not, may not influence significantly. So in that case, we will remove some variables from the model. I will give the example. See, so for example, obviously exclude variables have a significant influence. As I told you that whatever we can exclude, whatever we remove some unimportant variables, that variables also may have some significance influence or will be reflected in the random variable. Nothing but whatever we remove some variables. Okay. So the error term is depends on the removed variable or excluded variable also. Nothing but, so when you remove unimportant variable, one variable from the model, so the error term is nothing but the error value will be high. So the error may depends on the whatever you remove the variable. That is, we can write it is equal to Vt is equal to that beta and excluded variable plus VT. Then we will write, I will show you that. So whose values will be autocorrelate. For example, when we are removing any important variable from the model, so you may get more error values. So generally you may get error values will be correlated each other. So this may be called quasi autocorrelation. Quasi autocorrelation. So I will show you that in the next slide. The equations. Then third reason, specification bias, that is excluded variable case. See, specification bias. So if we use misspecification model, for example, when we are using a model which we don't know that, but when we wantonly use some model, we may get autocorrelation problem. So for example, see, in research, generally in research, the researcher verify the or results after according to the priori expectations. For example, generally if you are a researcher, after conducting a research, you will look at the results, whether our results are according to our priori expectation, nothing. But before doing analysis, we may have some thoughts. But that's why we can frame hypothesis. Then, as per our hypothesis or statements, whether our results are good or not. So nothing but whether our statement is accepted or rejected. In that case only, the researchers verify his results according to the priori expectations. Priori expectation, nothing but. So before analyzing, we have given we have some statements or nothing but we have some ideas. So as per our thought, whether the results are good or not. So for example, if you take into account an equation, see in the multiple regression, yt in time series is equal beta 1 plus beta 2 x2t, beta 3 x3t plus beta 4 xt 4t plus ut. This is the first equation. For example, where we can observe that is q is nothing but quantity of beef demand, then betas, that is a b's, this beta 1, beta 2, beta 3, beta 4, that are the coefficients or parameters. As I told you that x2, that is a x2, the beef demand is depends on price of beef. Then x3 variable, that is a consumers income. Generally, as per our law of demand, the demand is depends on price and income and substitute goods. See the x4 is a price of pork. Then t is nothing but time series, time in time. So this is a model. For example, as I told you that if I collect information from the beef demand in particular years, so if I want to know that what are the determinants of beef demand from 2000 to 2020, if I collect information from 20 years, for example 2001 to 2020, okay, so I need to collect information from how much demand in 2010 11, how much the price of the beef and price of the pork. So this is my and consumer's income. I need to collect information from the particular respondents or particular years. So this is good. This is a model we can use. For some reasons, we run following regression. For example, we may run like this. For example, see, yt is equal to beta 1, beta 2, x2t plus beta 3, x3t plus vt. This is the second equation. See, this is the first equation. The demand is depends on just a minute. Yeah, the beef demand is depends on price of the beef and consumers income and price of the pork. For some reasons, we can use only what are the determinants of beef only. We have taken. See here, yt is equal to beta 1, beta 2, beta x2t plus beta 3, x3t plus vt. Here, if the equation 1 is correct model or truth, the true relation, running equation 2 is tantamount to letting Vt is equal to beta 4 x4t plus Ut. And to extend the price of fork affect the consumption of beef. So when you are running this model, for example, when we have the other model in the first equation, when you run second model for some reasons, it means that you may not think that your just a minute, somebody is getting some voice. Say when you apply this model, for example, the demand for beef is depends on price of the beef and consumers income, but we have not taken into account that price of the pork. So there is also thing that so the price of the pork may not affect on consumption of beef, nothing but demand of beef. So if you run this equation or this model, it may be called misspecification. Sometimes the beef, that is the random variable also may affect on the nothing but it is the random variable is affected by the price of the pork. That is we can write it. See, Vt is equal beta 4 plus beta 4 x4t plus error term. To extend, the price of the pork affects the consumption of beef. Here, see, when the price of the pork also may affect on the beef. For example, if the price of the pork increases, most of the consumers may prefer to beef. So as we have studied that substitute goods, there is such as coffee and tea, the price of the tea is increases. So those who can consume, those who can drink the tea, so they may prefer coffee. The price of the coffee increases, those who can drink coffee, they may be preferred tea. Nothing but one of is the here the price of the pork may affects on the consumption of beef. So here the price of the pork increases, so they may be preferred to eat beef. That's why here the price of the pork affects the consumption beef. The error term, that is the V, will be reflect a systematic pattern, thus creating false autocorrelation. That creates false autocorrelation. So that is a misspecification of model. So is it clear, dear students? I think.
Yes, sir.
Yeah. So generally,
Yes, sir.
you can keep in mind this is very related to the law of demand. Okay. The next one, specification bias. What is specification bias? Here also there is an incorrect function form. Incorrect function form. So what is incorrect function form? For example, see, if you want to do a study on determinants of marginal cost. So as we have studied in microeconomics that the marginal cost, what is the marginal cost? How marginal cost increase or decrease? Okay. Then we need to understand that what are the factors can affect effects on marginal cost. Generally, the cost is depends on output. If your output is increases, your cost may be increases. Generally, if you take into account if you are using additional output, you may be your marginal cost also increases, or sometimes it will be decrease. It depends on the returns. Okay, that's why that is a returns to scale. There is increase in return or decreasing or constant. But so the marginal cost depends on output, right? Then, for example, if you take into account that Yt is equal to beta 1 plus beta 2 x2t plus ut. Here, Yt is called marginal cost. Beta 1 is nothing but constant or parameter, or B is coefficient or parameters. X2 is nothing but output, right? Ut is nothing but error term, right? So, is this correct model? Hello, dear students. Is this correct model? Is it incorrect model or correct model? Hello, Monica, Maheshwari, and Saraswati, other people. Hello, are you there? Is it,
Yes, sir.
is it correct model or incorrect model? For example, you have the data. For example, you want to study that what are the factors are affecting the marginal cost. అంటే మార్జినల్ కాస్ట్ నిర్ణయించే కారకాలు ఏంటి ఏంటి అవుట్పుట్ ఓకేనా సో జనరలీ అవుట్పుట్ is influencing the marginal cost, but whether this model is correct or incorrect. Yeah. See here. So this model is incorrect model, incorrect function form, because when we are taking into account the cost models, generally we need to take a non-linear regression, non-linear regressions. See how non-linear regressions are there. So it is incorrect function form. It is incorrect function form. The true and correct model in cost output study is as follows. For example, when you are measuring that what are the determinants of cost, uh, we need to take into consider this model. This model, that is yt is equal to beta 1 plus beta 2 x 2t plus beta 3 x2 square t x2 square x2 square t plus ut. So here see, here beta 2 x2 t, here beta 3 x2 square 2, sorry, x2 square t. Here whatever we are, sorry, here the marginal cost is effect on output, and at the same time the marginal cost is also depends on square root of output, square root of output. So generally in cost analysis, so generally the marginal cost is depends on output, as well as we need to take in economics analysis, that is the marginal cost is depends on not only normal output, so it is depends on square root of output, square root of output. So this is the correct model, this is the correct model, nothing but here ఏదైతే x2 వాల్యూ ఉందనుకో, ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ టేక్ ఇన్ టు అకౌంట్ if particular year x2 is equal to 2, so at the same time we need to square it, 2 into 2 4. So then another variable you need to take into consider the square variable, squared variable, nothing but output squared variable. This is the correct function form. So generally we will go with this formula, but most of the scholars they don't know that. So in cost output analysis you need to consider this kind of function form. So where marginal cost and b is coefficient of parameters. So x2 is output, x2 is output, then x3, see this is x2 square, there is a output square, output square. So note, simple, you can note a point that in cost function we have to go through power functions. As I told you that in cost and cost output analysis we need to go with the power functions, that is called non-linear functions. Non-linear function, nothing but the power value is more than 1, the power value is more than 1, so that is non-linear function or power functions, because here power value is equal to 2. Okay, then Cobweb phenomenon. Cobweb phenomenon. What is Cobweb phenomenon? So, for example, here, when you are studying in the agriculture economics, so the supply of agriculture goods reflects the so-called phenomenon, that is a Cobweb phenomenon, where supply reacts to the price with a lag of one period or one time period. So generally, the supplies depends on what? Price. So today supply, for example, if you take into account vegetables. So today, how much supplies comes to the particular market? That supply, the quantity of supply is depends on what? The price of the last day. Because if the price is good in particular market today, for example, most of the farmers they will sell their product or their commodities at the evening in the particular market yards. Okay, generally at morning also they will sell. So in the evening or night, uh, they may be sell in the particular market yards. So if they will go good price per kg or per quintal, what they will do? Simple, they will bring a lot of amount, nothing but lot of quantity tomorrow. By on tomorrow, they will bring a lot of quantity because the rate is good. The rate is not good, they may be decrease their supply to the market. Because if the rate is good, they may be bring more quantity of goods. Okay, so here the supply is depends on what? The price of the last day. So here where supply reacts to the price with lag of time period, because supply decision take
Gestation
time to
period.
implement. There is a gestation period also. Gestation period. Sometimes the supply, the quantity of supplies depends on gestation period. Nothing but they will guess. See, here supply in 2020 is depends upon the last year price. For example, if you take into account the paddy or cotton. So here, if you take into account supply of cotton or supply of paddy is depends on what, how much the government has given the MSP price in the last year. So if the price of the MSP, nothing but the price of the paddy is good, most of the farmers prefer to cultivate that kind of crop. For example, the government is giving more MSP price to the paddy, most of the farmers will cultivate the paddy crop, because so in the next year the supply may be high because the price is good. The price is not good in particular today this year, they may not cultivate in the next year because the government is not providing sufficient price to the farmers, so they may not prefer to cultivate the that kind of crops. So that is the example I have given. See, supply in 2020 is depends upon the last year prices, nothing but 2019 prices. The paddy or cotton, if you take any example, any crop, not only. See, this is a supply T 2020. It depends on the beta 1 plus beta 2 PT minus 1. PT minus 1 plus UT. So where ST is nothing but supply in current year. Supply in current year. Then beta 1, nothing but coefficients. These. Then PT minus 1. What is P? The year price. The supply depends on price. And supply is depends on previous year price or previous price with lag one. Here, see, price in 2019. Price in the 2019. If I take into account year wise. For example, if you take the Sensex, okay, the Sensex, if you take into account some particular share, the share, the quantity of supply of shares is depends on the previous day price of the stock or price of the share. Okay. So generally in agriculture, we will get Cobweb phenomenon, that is called present year supply depends on previous year price. For example, all else if you take into account vegetable market, today prices depends on what price? Last day price. For example, if your father is a farmer, they will bring a tomatoes to the market. The tomatoes per kg is 20 rupees. They will bring a one quintal, for example. So if the tomorrow they maybe go to the market. So if the price of the tomatoes will be increased from 20 to 30 rupees, what will happen? What will happen? See, if the price increases from 20 to 30 rupees, tomorrow your father may bring 150, nothing but 1.5 quintals, they may bring to the market because the rate has been increases. So today supply in the market is depends on what last day price in the market. So when you are taking into account the Cobweb phenomenon, see, as you have studied that Cobweb phenomenon like this, present is depends on previous that is depends on nothing but 2020 supply depends on 2019. So 2019 supply depends on 2018. 2018 depends on 2017. 2017 depends on 2016. Nothing but Cobweb phenomenon. మనం తెలుగులో అంటాము సాలె పురుగు సంథింగ్ అంటారు చూడండి. So how it can rotate like this? Okay, that point can depends on previous. That point can depends on previous, like this. Is it clear, these students?
Yes, sir.
Yeah. Next, sixth point, sixth reason, lags. Lag is nothing but so generally we can take lags in the time series data. So in time series, the dependent variable may also depends upon the its own with lags. See, present year supply depends on the its previous year supply also. The present supply depends on the previous day supply. You may expect in the market. See, for example, today in the market, tomatoes has arrived 100 quintals to the particular market. 100 quintals today. So this quantity of supplies depends on what last day supply. Okay. So generally the market people, they will think that today arrived 100 quintals. So tomorrow they will expect that around 100 quintals. It may be 105 or 95 also. So on the base of supply, the price may be determined. Okay. So here in time series, the dependent variable may also depends upon its own with lags. Nothing but present year depends on its previous year value. How it can be shown? Like, see, I will show you. The present year consumption expenditure is depends on what? Today your expenditure is depends on what? Last day expenditure. Generally, if you take into account for example, if your monthly expenditure or your packet money, for example, if you take into account, so your monthly expenditure is depends on previous month expenditure, right? So this present year consumption expenditure depends on upon other things, example income and consumption expenditure in the previous year. If you take year wise, for example, if you take into account your family expenditure in the month of November is depends on what, your family expenditure is November expenditure depends on October. Nothing but how much you spend in the October. Okay. So for example, in the December, for example, if you take into account, your November expenditure may influence the December expenditure also, because your taste and preference, your habits. Okay. We can write this equation like this. See, here the present consumption, nothing but I put at C, nothing but consumption in particular year, beta 1 plus beta 2 YT plus beta 3 CT minus 1 plus UT. Here where see CT nothing but present year consumption, Monica, please unmute. Yeah. Yeah, present year consumption is depends on what, income, that is a YT, and present year your consumption expenditure is depends on previous year expenditure. For example, if you take month wise also, no problem. This is a present month consumption is depends on previous month. Okay, so we can write this kind of equations because these are with lags. So when you take lags also, you may get some autocorrelation problem. So generally, if you take into account this model, for example, this regression is also known as auto regression because one of the explanatory variable is lagged value of the dependent variable. Nothing but one explanatory variable is nothing but this one. Is lagged value of the independent variable. Nothing but the present dependent variable is depends on its own with a lag. The CT is depends on CT minus 1. Okay. So the consumption is depends on income basically. So the present year consumption also depends on previous year consumption, right? So as you know that what is C here, consumption expenditure in the current year. If you take 2020, the beta is nothing but coefficients, YT is nothing but income, CT minus 1 consumption expenditure in the last year. If you take 2019, this is called lags. When you are using the lags also, you may get autocorrelation problem. Then seventh one, manipulation of the data. Manipulation of the data. How we can do the manipulation of data? See, generally in empirical analysis, the raw data is manipulated. When you are taking into account in empirical analysis, the raw data is manipulated. So generally, if you take in time series data, if you take quarterly data, the quarterly data is derived from the monthly data. For example, if you take into account GDP data is available quarterly also, monthly also. So how we can do quarterly data? See, the quarterly data is derived from the monthly data by simply adding the 3 months divided by 3. For example, data is available in the month wise. How we can take the quarter data? So if you take into account in the particular year, there are 4 quarters will come. January, February, March. There are 3 quarters data. We can add it 3 values, then divide by 3. Then we will get quarter data. So doesn't mean that you cannot take that March data. Okay, January data and February data and March data, we need to club it and we can divide by 3. How much will we get? That is called quarterly data. So another source of manipulation is interpolation data or extrapolation of data. Interpolation and extrapolation. For example, if you take into account census of population data, for example, if you take our generally we know that census data collect from the government of India will collect once in 10 years. 10 years lo ఒకసారి మాత్రమే census data collect చేస్తారు. For example, if you take 1991, 2000, 2011. Okay. For example, if you are, for example, if you are you are a researcher, if the researchers want to collect census data for some years with the inter-census that is called 2001 to 2011. If I need to collect information from 2001 to 2011, the common practice is what? To simply interpolate on the base of some adect assumptions. That is, after interpolate, the data may not be exist in the original data. So what we can do, see here, uh, the government will be published data on 2001 and 2011. Okay, how much 2001, for example, 102 crores in India. So in 2011, 121 crores. For example, I need to get in 2004 years data, for example. How I can get? Simple, I can add all the values of from 2001 to 2011, or else I will simple, I will divide into the equal parts. Think about how much I need it for quarterly, for example. If you take into account, there is a one institute in Institute of Popular Studies, IIPS in Mumbai, they will publish year-wise data. So, for example, if I want to know that between some years, then I will collect the data, but the data may not original data. The data is not an original data. That is called interpolation or extrapolation. Oh, okay. That is called, yeah. Then data transformation. Data transformation. So in empirical analysis, we do data transformation. That is the original data converted to the log forms. So generally, if you take into account when you do regression analysis, generally I told you in the second semester and first semester, log regression, nothing but log linear regression. So whatever your data is there, if you convert into the log forms, that is the natural logarithm form or simple logarithm forms or anti-logarithms. Then and if you take into account that is the equation Ct is equal beta 1 plus beta 2 yt, that is the consumption is depends on income. So where the consumption, the expenditure in current year and yt is income. For example, if you take this equation, there is a with lags, nothing but present year the consumption is depends on the previous year income also. For example, see the last year the thing, but last year consumption is depends on last year income. We can write that is Ct minus 1 is a function of b1 beta 2 yt minus 1 plus ut minus 1. It means that Ct minus 1 yt minus are the lagged values of c and y. Okay, so here see consumption in the last year is depends on last year income as well as last year error. So we can write this change. There's a drift. We can say in the economics term drift term. We can say simple delta. Ct nothing but change between from current year and last year. How much the difference is there between these two?